Hi guys, this is page 4 of Unit 10, Section 3, Solving Exponential and Log Functions. So page 4 is a whole bunch of applications of exponentials and logs. Here we are with the first example. We're trying to talk about population of certain bees. So we have the function to help model how that population increases after t days. So that's what t represents right there, and b represents the number of bees after so many days had passed. So the first question we need to find is the initial bee population. That means after 0 days, what is the number of bees? So that's what you need to think to yourself trying to find the initial population. Well, so we're going to replace 0 right there for t on that equation. So after 0 days, how many bees do we have? So, and here's what you're going to do to put that in the calculator. So you have a couple of different ways here. You can put that the way you see it, the way you set it up. So 900 over 2.5 plus 20 is that key right there, raised to the power of negative 0.05, and then we're replacing 0 right there. So you get 40 Bs. The other way, you're like, that's too many things for me to type. You can think about the power of 0. So notice how E is raised to the power of 0, and everything raised to the power of 0 equals 1. So in 1 times 20 is 20. So the other way you could put in the calculator is 900 over 2.5 plus 20. You get the same 40 Bs as the initial population. Now next, we have 3 different formulas. One of them is the compound interest, and then we have compounded continuously, and then we have the half-life. Based on what the situation gives you, that's how we're going to decide which one to use. A couple things you need to know is what each one of those variables represent. So on the compound interest, A is for balance. That's the final amount. P is for principal, or the initial amount. R is the interest rate, but not as a percentage, as a decimal. N is the number of times per year that the interest is compounded. Key right there is per year. Sometimes it will give you the number of times it's compounded differently. So then you have to think about how many times that would be in a year. And T times in years, same thing. So if you give you the number of days, then you have to change that in terms of years. So just be careful with the units right there between the number of times per years and time in years. Okay, the first one. Because over here says compounded monthly, that tells me I need to use the compound interest formula right there. So that's what that number 1 is telling me. So this number 1 tells me I need to use this formula right here for compound interest. And for every single problem, I like to label what I have and what the values I have for each variable. So the initial amount here is 1,200 at a rate of 7% compounded monthly. So 7% as a decimal is 0.07. Compounded monthly, number of times per year, so 12 months in a year that's been compounded. So how much is in Jonathan's account? So what is the final amount? What is the final value? What is the balance after 20 years? So T in years, so that one is fine. So just 20. Go ahead and replace each one of those values into your formula right there. And here is what your calculator is going to look like when you plug that in. So 1,200, 1 plus 0.07 over 12, and then everything raised to the power of 12 times 20. And since we're talking money, we need to round that to 2 decimal places. So 4,846 and 49 cents right there. So the next one, it says right there, compounded continuously. So the continuously, I need to choose the second equation right there. So that's what that number 2 is doing there. The initial amount or the principal is 6,500, so P is 6,500. E is about 2.718. You don't have to use that number. You can just use the key for E right there on the calculator. R is the rate, so 4% as a decimal is 0.04. And how much is in Kevin's account? It's funny because it goes from Nancy to Kevin. Account after 9 years. So T is 9 right there. So we're plugging the values right there for function or equation number 2 right there. So 6,500 is P. E, we're just going to use the key from the calculator, raised to the power of RT, so R is 0.04 times 9, and this is what it looks like in the calculator. 6,500 E raised to the power of 0.04 times 9. And that's dollars, so we need to round that to 2 decimal places, so 0.64 right there. Number 3, or the next one, we have compounded daily. So it's not compounded continuously. Since it's daily, I need to choose the first one, the compound interest formula. That's why the number 1 is there. A is what is the balance, what is the final amount after Sally buys a car for $15,000 in a rate of 16%, so 0.16, compounded daily, 365. Remember, N is the number of times per year, so daily, 365. Be careful with this one. What would be the total amount she owes after 13 months? Notice that T was supposed to be time in years. It gave us 13 months. 13 months out of a year, so 13 out of 12. Because we have 12 months in a year. So you have to make sure that you change that into terms of times in 1 year. Let's go ahead and put this in the calculator. You can do 13 divided by 12, or you can put the fraction right there, 13 over 12. Either way, you're going to get the same answer. Since we're talking dollars, we need to round that. Oh, I missed a 0 right there, so let's try this again. Okay, that's better. So 17,838 and 26 cents right there. Okay, 2 more. So the next one is continuously. So we're choosing equation number 2 or function number 2. These are my values. P is 100,000. Rate or percent. Rate is 5.5, so change that into decimal. 10 years. This one is pretty straightforward. So just punch it in the calculator. And voila, 173,325 and 30 cents. Now the last one, we're doing some chemistry here, haha. It's talking about a half-life, so I'm going to choose the half-life formula, and that is this one right here. So A0 is the amount of grams for the sample, the initial amount. And T and N are pretty much the same thing. The difference is T and N, in this case, is in days. Okay, so it's not in years anymore. The third half-life formula is just a little different, but it's the same idea. So it starts with 365 grams, 365, just kidding, 350. The half-life is 3.6 days, so that's your N. How much will remain after 21 days? So T is 21. Plug that into the formula. And then finally, put that in the calculator. If you want to use this as a fraction, that's fine. If you want to do 0.5 in the calculator, that's fine too. And that's where I got 6.138 grams left from the sample after 21 days. And that's all I got.